This is the module overview for Module 5 on materials, resources, and waste systems. We're going to be talking about the resources and materials that go into consumer products, packaging, and construction materials, and the materials that we build our environment with. So we'll be talking about consumer decisions, we'll be talking about professional engineering and design decisions when we consider materials and resource use. We'll also be talking about the life cycle of a product, from the extraction of the raw materials to make the product, to the production and manufacture of the product, which is oftentimes multiple phases, to consumption of the product, what happens when the product is with the consumer, and then the waste that results when the consumer is finished with the product. It's important to note also that waste occurs in the form of emissions, either to the air, land, or water at all phases of a product's life cycle. When we talk about ecosystem services related to resources and waste, these are the services that are impacted. Carbon storage is impacted because trees and soil are removed to harvest or mine materials and resources to make products. Biodiversity is impacted because habitat is impacted. Human health is impacted really at all phases of a product's life cycle. We'll talk in detail about how that happens in later in this module and in other lectures in this module. Later in this lecture, I meant. Clean air is impacted, and then of course wood is a provisioning ecosystem service. When we look at the UN Environmental Programme Sustainable Development Goals report, Goal 12 is about responsible consumption and production. And the goal is to ensure sustainable consumption, in other words, our sustainable use of resources, and production patterns. So that means the production of products and materials. Unfortunately, we currently don't do that. We use a lot of materials and products, and we create a lot of waste. So our consumption is pretty much out of control, particularly in this country. Also, it's important to note that our material footprint, the materials that we use to make products, is growing so rapidly, it is outpacing population and economic growth. But the good news is that nearly 100 countries are actively adopting policies and measures to promote sustainable consumption and production. There are some policies in the US that are promoting sustainable consumption and production, but not that many from our government. There's more some nonprofits that are promoting this. But you can see that, you know, that our global footprint has grown rapidly. Has grown rapidly in the last 25, 27 years, and it's projected to grow even more rapidly by 2060. It's also important to note that the higher income countries like the US and the UK and European countries have a much higher footprint in terms of resource use than low income countries. You can see here, our footprint is 27 metric tons per person in our lifetime in a high income country versus 2 metric tons per person in a low income country. And of course, in the middle for the upper middle income countries. Our material footprint per capita has also been growing substantially. So here's us, we're a high income country. In 2000, this was our metric tons of material footprint per person. And in 2017, we've grown. You can see worldwide, though, the footprint is growing at an even more rapid rate. So this is something to be very concerned about. looking at this on a country by country basis, we have some countries that have ecological deficits, and other countries that have ecological reserves. The countries that are in red or pink, some form of red or pink, actually have a material footprint that is greater than their biocapacity. In other words, they cannot support their material consumption with the biocapacity that they have. Biocapacity meaning capacity to produce the resources or mine the resources that they will use. So in the US, we're a biocapacity debt. So we use resources from around the world to make the things that we want to consume. Whereas in Brazil, say, they have biocapacity credit, and we use resources from countries like Brazil to make the things that we use. So let's look at this a slightly different way. Getting back to our ecological footprint that we looked at in Module 1, you will recall that your footprint probably needed around 5 Earths to sustain your lifestyle. On average, in 2017, the US needed 5 Earths to support the life cycle, the lifestyle that we are accustomed to, and our consumption patterns that we're accustomed to. In the UK, they need just a little over half the number of Earths that we do to support their consumption rate. China, it's a little less. And India and Nigeria, here we see that they actually need less than an Earth to support their consumption patterns. But you're probably saying, well, there aren't 5 Earths, and there aren't. So something's got to give. And we're going to talk in this module about how we can reduce our consumption individually, but more importantly, some of the ways that we can reduce consumption when it comes to production and use and disposal of material resources. So looking a little closely at the US consumption, this is a chart showing US consumption from 1961 to 2017. You can see that the biocapacity of the of the US has decreased. It's hard to tell, but it's decreased slightly. And the ecological footprint has increased slightly, but because our biocapacity has been reduced because of the resources we've already used, our biocapacity deficit has grown. So it's 4.6 is our biocapacity deficit. So every country this data is available for. If you're interested, you can go to the World Development Indicators at the World Bank to get this information. So just think back on your ecological footprint. You may want to go take the test again and just see what you know now that we know a little bit more about materials and resources and their impact on the ecological footprint. Remember, food choices impact it, transportation choices impact it, etc. So in this module, we'll talk about consumption. And I think this movie, The Story of Stuff, which is a very short, I believe around 20 minutes, will really do a good job of giving us an overview of our consumption patterns in the US and why we consume so much, and the forces, the sort of invisible forces that are causing us to consume more, like our addiction to consumption and the hyper-consumption that we're encouraged to engage in every day through advertising, etc. We'll also watch the movie, The Story of Plastic. This is a little bit longer documentary. It's a new documentary that just came out last year by the same people who made The Story of Stuff. And it'll talk about the impacts of plastic use on the environment and on human health and on ocean health. It's quite a great movie. So I was shocked that we have a man-made or a human-made mass, what you might call anthropomass, that is greater than biomass on Earth. So there are trees and shrubs on Earth are estimated to weigh 900 gigatons. Buildings and infrastructure around the world now weigh 1,100 gigatons. So the man-made, human-made mass is greater than the mass from the biomass. Also, plastic in use and plastic waste is 8 gigatons, and animals, all the animals, including insects and organisms on Earth, are just 4 gigatons. So you can start to understand how prevalent the human-made resource use and footprint is on this Earth. So in this module, we'll talk about the environmental impacts of resource use, ranging from the fact that many resources we use are non-renewable, habitats are destroyed to mine or extract or harvest these material resources. As a result, the water quality on or near the places of mining and the places of manufacturing is impacted. Air pollution, air quality is impacted. So many impacts, and not the least of which is from the waste that gets released when making these products and materials. This statistic shocked me the first time I heard it, but the more I know about this topic, the more I know that it is true. More than 90% of the material that goes into the average US product is waste before the product even reaches the users. We'll look at an example of that in just a minute. But it's important to note that this waste might be released to the land. It might be put in a landfill. It might be released to water in the form of an effluent, or even in the form of solid particulate waste that's released to the water. It also might be waste that's released to the air in the form of air pollution emissions. It could be particulates, and it could be CO2. And in fact, the largest dumping ground for waste is our air. And CO2 is a huge part of that. So this will become really clear to you when you look at this diagram. There's a concept in material science called total material flows. And this is the total quantity of materials removed from nature, whether it's the earth or from biomass, to create a product. So there are 3 different kinds of material flows. There are hidden flows, indirect flows, and direct flows. Let's look first at hidden flows. And this is a diagram showing the steel to make a car. So first off, mineral is mined to obtain the steel. And you need 3 times the amount of material to be mined to obtain 1 amount of iron ore. So in order to get 1 ton of iron ore, you have to remove 3 tons of material. And all of that material that gets removed is rock, it's soil, it's trees, it's all the things that you need to take out to get to the iron ore. And that's called a hidden flow. Things that just don't show up very obviously, but they are still waste. When you think about that, already now we have 75% of the steel material is waste before it even gets to the factory. Then the crude ore is transformed into a material that's starting to look more like steel or iron. And the fuel that's used in these processes are indirect flows. That is also fuel is resources. And then the water and the waste that comes out of these processes is part of the hidden flows. Lastly, we get the pig iron and we make it into steel, and we use more fuel, but the steel and the fuel is a direct flow. So this will give you an idea. You can start to see just how much waste and hidden flows are happening, and indirect flows are happening in the making of a material. So we'll also talk in this module about consumer waste. And so this chart is looking at how different countries dispose of both manufacturing waste and consumer waste. And it shows the percentage of landfilling the waste, incinerating the waste, composting the waste, or recycling the waste. The US isn't at all the worst, but it sure isn't the best either. So we'll talk about some of the impacts of these different methods of disposing of waste. But the third large piece in when we talk about materials and resources is the toxicity that may result from as a byproduct of making products, or it may be a part of the product, or maybe it's the product itself. And these are all things that we need to be concerned about when we talk about materials and resources and product production. You can see this stat of the 80,000 synthetic chemicals in use today, 85% have not been tested for human health impacts. So in some cases, we don't know whether the materials that we're using are harmful to people. In other cases, we do know, and we may still be using them because there's some dispute about that, their harm. And then in other cases, we know about the harm and we stop using the materials. But this image in the background is a train crash in Connecticut a few years ago, and it shows tanker cars of a train that were filled with vinyl chloride. Vinyl chloride may sound familiar to you, and it's because PVC, plastic, is polyvinyl chloride. It's the building block for your shower curtain or your kitchen floor or your desktop in your classroom or the rubber duck in your bathtub. PVC is a very common plastic, yet the main ingredient of PVC was used as a chemical weapon in World War I and was banned by international treaty after World War I. So it's a very, very harmful chemical. We contain it, so we think it's safe to use until we have a train wreck like this. And then all of a sudden the entire town has to be evacuated because it poses such a threat to human health. So toxicity is another big issue that we'll talk about. So there are social impacts to product manufacture, whether it's a social impact from the raw material, excavation, or from the factories like you see here, or from the transportation of the product, or from the disposal of the product. And if the product is incinerated, sometimes toxic gases are released. So it's not an accident that many of these toxic releases and social impacts happen near marginalized communities. So we'll definitely be talking about that in this module as well. A separate lecture will deal with the product life cycle. This is the diagram that we looked at the beginning, and we'll be looking at phases of this life cycle. The typical product life cycle right now is a linear life cycle, and it might be we take resources from nature, we make something with it, we use that thing, and then we dispose of that thing. So this is sort of showing a very wasteful life cycle of materials. So we will talk in this module about ways to sort of focus on a circular economy where we use a product, we collect it after we are done using it, we transform the materials of the product into something where we make a new material or product, we use it, and we're working towards a circular life cycle and a circular economy. So we'll talk about that in this. And that circular economy deals with what's called a closed loop system, where waste from one process is food or feeds another process. This may seem a little obtuse right now, but we'll go into this in much more detail in another lecture. We'll also talk about what responsibilities producers have to to you as a consumer, and what responsibilities they have for seeing to the safety of their products, both before you use it and the safety of their products after you use it. Here you can see an Apple facility recycling phones. There is a relatively robust market for trading in phones. They refurbish them, they sell them. But in some cases, when the phone is just complete waste, the company will take back the phone, take it apart, safely recycle its components. And in electronics, this is a particularly important thing to do because of so many of the toxic constituents in our current electronics. So we'll talk about product take back and disposal as a type of extended producer responsibility. We'll also talk about transparency that producers should be providing to consumers. They should provide comprehensive, accurate, and verifiable information about their products and practices. So just like we get a nutrition label on our box of cereal, we should also be able to get a nutrition label about the impacts of the product, whether it has toxic constituents, as is shown here. You can see polyvinyl chloride is red, chromium 11 is also red. These are both toxic constituents of this product, which happens to be a toilet. So that is a type of producer transparency. We'll talk about how there are many third-party systems that are verifying the information that's coming from producers and product manufacturers. The reason that we need third-party verification is we need a neutral third party to say whether this information is correct or not, because as you know, product manufacturers can say just about anything, and they do. So lastly, we'll talk about two certification systems. The first is the cradle-to-cradle certification. And this certification system looks at all kinds of consumer products and building products and the impacts that they have on material efficiency, reusing materials, healthy materials, non-toxic materials, their use of renewable energy as they produce these products, their use of water as they produce these products, and the way that they treat their workers and give opportunities to all types of workers. And then we'll also look at the Living Product Challenge, which is another certification system from the International Living Future Institute, where they ask product producers to harvest raw materials in a relatively safe way, use water efficiently, use energy efficiently, avoid toxic constituents, use material resources efficiently, be fair to their workers, and of course, create products that are beautiful and functional. So you'll be looking in depth at the Living Product Challenge as well. So as we look back on the module objectives, we're going to talk about the habitat loss, climate change, consumption, purchasing, product manufacturing, and waste. We'll look at principles, theories, and strategies of resource conservation and waste minimization. We'll compare the frameworks we just talked about. We'll evaluate and compare the life cycle impacts of two products, and we'll evaluate product and corporate sustainability claims about products and processes. Thank you.